So what we're going to start today are solids of revolution. Last class we did a volume of solids where we did cross sections and they were shapes. Now what we're going to do is we're going to take an area and spin it in order to create a three-dimensional object. So I'm going to share my screen and we'll go through this Desmos activity together here. And it just helps you to like see and visualize the objects that are being created. I'd love for you guys to be able to respond in the chat, but I have trouble having the chat and everything else open when I'm sharing my screen. This is real short. We'll just go through it together. There'll be plenty of other things you guys can chime in on. All right, so we're going to take this rectangle and we're going to rotate it around the x-axis 360 degrees. So it's going to spin around. So what figure would it form? That is going to be a cylinder. And in the next slide or the one after, there it goes. So it's going to take that shape and spin it around. So you can see sort of, it does an okay job of it, that it's going to be three-dimensional. It's going to be a cylinder. So the radius of the cylinder goes from here to here. So that is 5. Our radius is 5. Tells me great job. Thank you. What is the height of the cylinder? So that is from here to here. It's going from -1 to +5. So that's a distance of 6. So our radius is 5. Awesome. And our height is 6. So then it's asking for the volume. So I'm going to do this on a little whiteboard here. Your volume for a cylinder, and if you didn't know this, you could have, Googled it or looked it up. Volume is pi r squared h. So this is our formula for the volume of the cylinder. And we said that our radius is 5 and our height is 6. So I'm just plugging in the 5 and the 6. 5 squared is 25 times 6 would be 150. So we get 150 pi. And again, they don't usually put units for these, but if there were units, it would be units cubed. We'd have, whatever it is cubed. It's three-dimensional. So that's just to help you visualize and see the three-dimensional object that's being created there. Nice work. And we're going to go through another one. So this time it's a triangle. We're going to do the same thing, spin it around the x-axis. And so that is going to create a cone. And so here they're going to show us, you can see it spinning around there. So that's going to create a cone. What is the volume of the cone? Again, if you didn't know the volume formula for a cone, you could have Googled that or looked it up. It is the same as a cylinder, except with a 1/3. So it's 1/3 of a cylinder, 1/3 pi r squared h. And so again, I'm going to plug in the r and the h to this formula. So that cone, the radius has to be from the biggest part here, the radius of the base. So it looks like that radius is 3. So let me plug 3 in for r. And then the height, this is not very well labeled on the axis here. What is that? From 0 to 3, we're halfway in between 2 and 4. So the height is also 3. It's not very much to scale there. Lots of 3s in that problem. So the radius and the height were both 3. Let's see, the 1/3 at the front and the 3 at the end are going to cancel. So those are gone. 3 squared is 9, so we get 9 pi. And again, it would be units cubed, whatever the units were. They just usually don't give them. All right, so 9 pi for that one. So again, we're finding a volume. Woot woot, it says for that one. All right, would it be possible, yes or no, to make a rectangular prism? This is by rotating something. This is what a rectangular prism would look like. Let's see if I can draw one. No making fun of my picture here. So a rectangular prism would look like that. It would be like a box. So the answer is no. The answer to the question is no. You cannot create a rectangular prism by rotating around a line because rotation means it's going to go in a circle. You're going to have something that is a circle. So it must be circular. All right, so you're not going to be able to end up with a box. All right, and then these are the cross sections. Don't look at this one because we're not going to do that. This is the one I want you to look at. What we're going to do is it's basically like the cross sections. We're going to, have all our slices of cross sections. It's just for these, your rotation, every single cross section is a circle. And it's called the disc method. They're all going to be discs. So it's a lot like what we did last class. It's just, you don't have to worry about all the different shapes. They're all going to be circular. Area of a circle is pi r squared. So every single one of these for the disk method is going to be pi r squared.